Hydrogen, the lightest element, is a colorless gas and the primary constituent of stars. Helium, a colorless, odorless gas used in balloons and as a coolant in cryogenics. Lithium, a lightweight metal used in batteries and for treating bipolar disorder. Beryllium, a strong, lightweight metal used in aerospace and electronics. Boron, a metalloid element often used in ceramics and as a neutron absorber in nuclear reactors. Carbon, a key element in organic compounds, forming the basis of life and materials like graphite and diamonds. Nitrogen, a diatomic gas, making up a large part of Earth's atmosphere. Oxygen, essential for human respiration and abundant in the Earth's atmosphere. Fluorine, a highly reactive nonmetal, commonly used in toothpaste and refrigerants. Neon, a noble gas known for its use in colorful signs and lighting. Sodium, a highly reactive metal and a key element in table salt. Magnesium, a lightweight metal used in alloys and as a dietary supplement. Aluminium, a lightweight, corrosion-resistant metal used in various applications, including packaging and construction. Silicon, a semiconductor material used extensively in the electronics industry. Phosphorus, an essential element in DNA and RNA and used in fertilizers. Sulfur, a nonmetal used in the production of sulfuric acid and various chemicals. Chlorine, a highly reactive halogen used in water treatment and as a disinfectant. Argon, a noble gas often used in welding and as a protective gas in various industrial processes. Potassium, an essential nutrient for humans and plays a role in nerve and muscle function. Calcium, vital for bone and teeth health and involved in various physiological processes. Scandium, a rare transition metal used in aerospace applications. Titanium, a strong, lightweight metal used in aerospace, medical implants, and sports equipment. Vanadium, a transition metal used in steel alloys and as a catalyst in chemical reactions. Chromium, a transition metal used in stainless steel and as a dietary supplement. Manganese, a trace element important for metabolism, and as an alloying agent in steel. Iron, crucial for hemoglobin in blood and widely used in construction and manufacturing. Cobalt, used in batteries and as an alloy in the aerospace industry. Nickel, used in stainless steel, coins, and as a catalyst in chemical reactions. Copper, a versatile metal used in electrical wiring, plumbing, and coins. Zinc, used in galvanization and as a dietary supplement. Gallium, a metal used in semiconductors and in high-temperature thermometers. Germanium, a semiconductor material used in electronics. Arsenic, has various uses in industry but is also highly toxic. Selenium, used in electronics and as a dietary supplement. Bromine, a halogen used in flame retardants and photographic chemicals. Krypton, a noble gas used in lighting and lasers. Rubidium, a soft, silvery white metal used in atomic clocks and research. Strontium, used in fireworks and as a component in some medicines. Yttrium, used in LED lights and superconductors. Zirconium, used in nuclear reactors and as a component in dental implants. Niobium, used in superconducting materials and aerospace applications. Molybdenum, used in steel alloys and as a lubricant. Technetium, a radioactive element used in medical imaging. Ruthenium, a transition metal used in electronics and catalysts. Rhodium, used in catalytic converters and as a jewelry material. Palladium, used in catalytic converters and electronics. Silver, used in jewelry, coins and photography. Cadmium, used in batteries and pigments. Indium, used in semiconductors and LCD screens. Tin, used in cans and as a solder. Antimony, used in flame retardants, and as a semiconductor. Tellurium, used in alloys and as a semiconductor. Iodine, used in medicine, photography, and as a disinfectant. Xenon, used in xenon headlights and lasers. Cesium, used in atomic clocks and oil drilling. Barium, used in fireworks and in medical imaging. Lanthanum, used in carbon lighting and optics. Cerium, used in catalytic converters and as a polishing agent. Praseodymium, used in magnets and as a component in some alloys. Neodymium, used in strong magnets for various applications. Promethium, a radioactive element used in nuclear batteries. Samarium, used in magnets and control rods in nuclear reactors. Europium, used in phosphors for color TV screens. Gadolinium, used in contrast agents for MRI scans. Terbium, used in fluorescent lamps and as a dopant in solid-state devices. Dysprosium, used in high-strength magnets and lighting. Holmium, used in lasers and as a component in some alloys. Erbium, used in optical amplifiers and lasers. Thulium, used in lasers and portable X-ray devices. Ytterbium, used in lasers and as a dopant in materials. Lutetium, used in PET scans and as a catalyst in some chemical reactions. Hafnium, used in nuclear reactors and as a superalloy component. Tantalum, used in electronics and as a component in medical devices. Tungsten, has a high melting point and is used in electrical wires and light bulbs. Rhenium, used in high-temperature superalloys and as a catalyst. Osmium, the densest naturally occurring element, and is used in some electrical contacts. Iridium, used in spark plugs, electrical contacts, and in some jewelry. Platinum, used in catalytic converters, jewelry, and some medical devices. Gold, valued for its rarity and used in jewelry, coins, and electronics. Mercury, a liquid metal used in thermometers and some electrical switches. Thallium, used in high-temperature superconductors and as a rat poison. Lead, used in batteries, bullets, and as a radiation shield. Bismuth, utilized in a variety of industries. Bismuth is often found in cosmetics like eyeshadows, as well as Pepto-Bismol for stomach ailments. It also serves as an eco-friendly substitute for lead in items such as shot and fishing sinkers. Polonium, notoriously radioactive, polonium has been employed in anti-static devices but is generally considered too hazardous for widespread application. Astatine, this radioactive halogen is so rare that it's mostly relevant in theoretical scientific research rather than practical applications. Radon, this noble gas is radioactive and naturally occurs in the Earth's crust. It can accumulate in poorly ventilated areas like basements, posing a health risk when inhaled. Francium, an extremely unstable radioactive alkali metal, francium has no significant applications due to its short half-life and scarcity. Radium, once commonly used to make glow-in-the-dark paints and clock dials, radium's radioactivity was later deemed too dangerous, leading to its discontinuation in consumer products. Actinium, this radioactive element mainly serves as a neutron source and a precursor in the production of other radioactive isotopes but doesn't have many widespread uses. Thorium, notable for its potential as a cleaner alternative to uranium in nuclear reactors, thorium is also found in gas lantern mantles and certain types of glass. Protactinium, while it's radioactive, protactinium doesn't offer much in the way of practical applications due to its scarcity and high toxicity. Uranium, a heavy element well known for its role as fuel in nuclear reactors and in the production of nuclear weapons. Neptunium, though radioactive, neptunium can be used in neutron detectors and occasionally serves as a precursor for plutonium production in reactors. Plutonium, highly radioactive and energy-dense, plutonium is employed both in nuclear weapons and as a fuel source in certain types of reactors. Americium, often found in common household smoke detectors, americium also serves as a neutron source in research applications. Curium, known for its radioactivity, curium is used mainly in research and in specialized applications like powering deep space missions via thermoelectric generators. Berkelium, its radioactivity limits its use to targeted scientific research, often involving the synthesis of heavier elements. Californium, valued in industrial applications such as neutron radiography, where it's used for detecting defects in metal parts. Einsteinium, its high radioactivity confines it to research purposes, specifically in the synthesis of other elements and in studying the properties of heavy metals. Fermium, due to its extreme radioactivity and scarcity, fermium's applications are mainly confined to scientific research. Mendelevium, named after Dmitry Mendeleev, this element is largely confined to research due to its high radioactivity and scarcity. Nobelium, largely limited to scientific research, nobelium's radioactivity and short half-life make it impractical for other applications. Lawrencium, a highly radioactive element primarily produced for scientific research, especially in understanding the properties of superheavy elements. Rutherfordium, a human-made element mainly produced in particle accelerators, it's primarily used for scientific studies on the behavior of heavy elements. Dubnium, also synthesized, dubnium's primary role is in scientific research, where it helps scientists understand the properties of heavy, unstable elements. Seaborgium, named after chemist Glenn T. Seaborg, it's synthesized for scientific research aimed at understanding superheavy elements. Bohrium, generated for research purposes, bohrium helps scientists explore the theoretical frameworks surrounding synthetic elements. Hassium, primarily produced for scientific research, hassium's high instability makes it unsuitable for practical applications. Meitnerium, created for the sole purpose of scientific study, meitnerium's short half-life limits its possible applications. Darmstadtium, crafted through particle collision techniques, darmstadtium serves as an experimental focus in the scientific quest to understand the characteristics and behaviors of elements with extremely high atomic numbers. Roentgenium, manufactured for the express purpose of academic inquiry, Roentgenium's extreme instability limits its applications to highly controlled research settings, prohibiting any commercial or practical use. Copernicium, produced using advanced particle accelerator technology, copernicium is chiefly investigated to shed light on the characteristics of elements with substantial atomic mass, including their potential reactions and stability. Nihonium, fabricated in controlled environments for research purposes, nihonium serves as a valuable subject in scrutinizing the specific chemical interactions and attributes of elements that reside in the superheavy category on the periodic table. Flerovium, scientifically engineered, flerovium offers researchers a chance to explore how elements with atomic numbers higher than those in the actinide series behave under various conditions. Moscovium, manufactured solely for academic investigations, moscovium provides key insights into the properties of extremely heavy elements, offering a window into an exotic region of the periodic table. Livermorium, developed exclusively for research initiatives, livermorium functions as a laboratory subject for scrutinizing both the chemical and physical facets of elements that fall within the superheavy category. Tennessine, crafted for academic exploration, tennessine serves as an instrumental subject in research designed to illuminate the properties of elements characterized by both significant atomic mass and instability. Oganesson, Named in honor of Russian physicist Yuri Oganesson, this synthetic element is confined to the realm of research, where it is examined to understand the unique behaviors and attributes of superheavy elements.